In example 1, you were asked the following questions regarding this function f of x, which is 1000 times 0.76 to the x power. First, you're asked, is it exponential growth or exponential decay? And from what you learned in 5.1 to 5.4, the common factor, which is the base being raised to the exponential power, this is less than 1. So this would indicate that you do have a decay. The initial value is the constant that's being multiplied to this. So that's going to be your 1000. And of course, the constant factor was already mentioned as being the 0.76. Now, when you talk about percentage rate of change, the percentage rate of change is going to indicate both growth or decay, in this case decay, so it's going to be a negative value. And when you're dealing with decay, the more complex thing about it is this formula, and any formula you have dealing with exponential growth or decay, is always telling you about the amount you have present. So after each x occurs, you're going to have 76% left, which means that you're going to be losing 24%. So that's why whenever you talk about the percentage rate of change down here, it's going to be a negative 24%. Meanwhile, when you have a growth factor like this, because this is a growth function, you have this value here that's over 1, so it is growth. The initial value, again, is this constant of 400, and of course the constant factor is 1.036. This, in decimal form, is basically saying that each time that x occurs, you're getting 103.6% of the previous value. And since you're getting the previous value plus 3.6% more, you're gaining 3.6%. And that's what the rate of change would be down here, a gain, which would be positive of 3.6%. So you have this situation here now. The population of Sorrentinoville is described by the function P of t equals 2,485 times 1.017 to the t over 6 power, where t represents the number of years after 2000. So first of all, keep in mind, because Top Hat has its own way of presenting this and Canvas has other ways it could be presented, you may see something like this with a fractional or rational exponent, either presented with t/6 like this, more left to right in this kind of function, or it could look like this. You have t over 6 instead. Keep in mind they mean the same thing. Just wanted to make sure to verify that you knew that for sure, although most people would probably have figured that out. I just want to make sure to stress that a little bit. So as we look at this function here, you can see 1.017 is indicating a value that's over 1 for your common factor. This is basically 101.7%. So this is definitely going to be a growth, and the population in Sorrentinoville is increasing. And since this represents 101.7%, that means that it's growing by 1.7%, but it's not every year. Because of this division of 6 you see in the exponent, it happens every 6 years. So the population of Sorrentinoville is increasing by 1.7% every 6 years. And so when I ask what is the initial population, well, the initial population is the initial value, and that's the constant still, so that's 2,485 people. And they're asking here, what is the population of Sorrentinoville in 2022? And so you want your t value, because your t value represents the number of years after 2000. That means that t is going to equal 22, and so you're going to substitute that in and carry through the calculation. And when you do that, you get about 2,485 times 1.01 to the 3.6 repeating power, which is what this becomes. Now, if you use this, this kind of indicates how much it's increasing in total over that time. It's going to be basically 106.375% of what it was in 2000. And that's 2,643.44, which rounds to 2,643 people. Likewise for this, you have the gallons of water in a local pond is described by the function g of t equals 23,000 times 0.908 to the t over 15 power, where t represents the number of months past January 2010. This Conlon factor right here is less than 1, so we know it's decaying or decreasing. And when you talk about decreasing, you have to make sure that you're aware that, again, this is going to basically represent the amount present or the percentage present after a certain period of time and not the amount lost. So this one here, this is 90.8%, which means you're losing 0.092 decimal wise or 9.2%. And that happens every 15 months because of the denominator. So the amount of water in the pond is decreasing by 9.2% every 15 months. And so the initial amount of water in the pond, of course, is the constant being multiplied out here. That's 23,000. And the amount of water in the pond on September of 2022, well, you're starting with 2010. So here, and you're going by months. So that's January 2010 to September of 2022. So you're going from January 2010 to September 2022. That's 152 months that go by. And so that's the value you want to substitute into the function for t. And when you do that and calculate it out, now as you do these, try to keep the fractions involved in all the decimal places you can. Do not round anything until you get to the final calculation. If you rounded to whole number of gallons, each one of these steps, you would get a little bit further and further away from the actual answer, enough to mean a significant difference. And so if I multiply these together, there'd be 8,649.6, so about 8,650 gallons of water is left in that pond by September of 2022. And so that is the end of this problem, and that is the end of this video. If you have any additional questions, please bring them up during our class session.